Sorry about that.
Oh, all good, all
Go
good.
ahead.
So each square is cut up shirts, purple shirt and a gray shirt to make it look like a checkers. And we weaved them together and tied them on the back. Hold on. This way.
Can you see what you're doing? No,
Um,
Get,
So, so are they just woven together? Or are they stitched together? How are they putting? How'd you put them
They're
together?
just
just
they're just woven together.
yeah,
Okay.
and then tied on the back for to get it tight, and then
What keeps it rigid?
oh,
Pardon?
there's a cardboard. Oh, foam. It's foam.
Oh, it's a foam material. Okay,
Yeah,
sounds good.
yeah. And
It
then
looks nice. Actually,
thank you
did you watch the video?
of
Uh,
the
uh,
shirt weaving.
Yeah.
Yeah,
yeah. Okay.
yeah, we
And
did.
whose shirts did they use? Whose shirts did you use?
Oh, these were
Miss
Miss
Moons.
Moon's old
Oh, okay.
shirts. Yeah.
You guys couldn't
Thank,
even
thank,
donate your own shirts. Come on.
right off her back. Thank you, Miss Moon.
Yeah, thank you, Miss Moon.
Thanks.
And then so we are molding. Here, show the bags.
So we're using like plastic bags and a heat gun
Oh,
to like mold it together into like kind of looking like that shape.
and then
Yeah,
have
very good.
we have hooks at the end, so they're gonna hook into these. We have L brackets that we're gonna hook into these little like it's kind of hard to show like that.
Yeah, the
Okay, very
bands.
good. Yeah.
Okay, and then after a piece is taken or like killed, we're melting Capri Sun packages together because they kind of represent like the water pouches that you showed us,
Mhm.
and we're gonna make a bag out of those. And then yeah, if the melting doesn't work, we're gonna hand sew them.
So how did you so what piece did you just show us? What is that a
Oh,
pawn
this is kind of
or a
like a
bishop?
just a test.
Yeah,
This
that
isn't
was
really
just a test.
this isn't really a real piece. We're gonna focus on like the actual shapes of the pieces later.
Okay. And so right now that just looks very cylindrical. What how do you want to mold that into different pieces?
Um,
So we were gonna do like simple shapes almost because with like the heat gun it's kind of hard and we have to act quick so it'll not cool off as quick. And so we were just gonna do like simple shapes for the different pieces.
I'm okay with that. And part of what I'm asking is, you want to have there has to be a certain amount of consistency, right?
yeah,
And so how do you want to make it so it's not just one blob and then another blob, but you can say, okay, this one is definitely a pawn, this one is definitely a bishop, that kind of thing.
yeah, we'll probably do like different sizes too. So like whatever we choose for the shape of the pawn, regardless of what shape it is, it'll be much. It'll be smaller than like a bishop or a rook, and then the queen and king will be the biggest pawns, obviously.
Well, consider, you can 3D print some kind of a mold. Does that make sense?
Yeah,
And what I'm thinking is if you've got make yourself a mold of a pawn, right? You heat up your plastic and then maybe you spray a little bit of water inside your mold and then you clamp it around your plastic. And I think that might give you enough, it would cool off quickly and then still be able to be removed quickly. Does that make sense?
Yeah.
yeah.
And you're are you using like what are you using for your hook material? Is that like a paper clip or something?
We could do a paper clip or we were thinking an aluminum what?
Like an L bracket.
And like an aluminum L bracket.
Oh, that's a great idea. Any kind of material you want to use there. Just looking for something kind of consistent, right? And that way it'll fit into your board a little bit easier as well.
Yeah.
Is that okay?
Mm-hmm.
Okay. Tell me
Thanks
some
for the
more.
idea. Oh, hold on.
Just writing down some of your ideas.
Okay. And that what you choose, you'd want to choose like a higher temperature 3D print material Because I think your polyethylene plastic bags are a great idea. We're going to have Ziploc bags, so that's not a problem. And so I think um, that's a fairly low temperature plastic, and you might be able to use those. I think that that's a good idea. Just putting a little bit of water inside there, I think will keep it from cooling off or from transferring too much heat to your mold. Is that okay?
Yeah.
So what
Okay.
about your color? You need a pawn black and a pawn white or some other two different
Yeah.
colors.
We were thinking like one set could be clear, and then one set could be like silver.
That would be good.
Oh, I see. And that's what the
Yeah, because one set could be like the plastic bag color, and then the other could be like the Capri Sun or like water pouch thing color.
Okay. Well, and remember, because yes, it's got some polyethylene in there, but that aluminum foil that's part of that is probably going to make that difficult. But try that out. If not, another option is on Ziploc bags, you've got that colored top, right?
Yeah.
What if you cut that colored top off? Now you've got the green for one set, and you've got the plastic bag, the transparent plastic bag. Does that work?
Yeah, that sounds like a good idea.
Yeah,
actually.
because then you
Write
could
that
put
down.
this color in.
But try out your Capri Sun thing. See if that
this.
works.
Yeah.
Okay.
Yeah.
And even if it's not all green, as long as it has some green on it that distinguishes it from the clear,
Yeah.
you're good.
Tell each other apart.
Yeah. So I really like your board.
I like the
you.
board as
Yeah,
well.
too.
I think that looks pretty good.
Yeah, I'm pretty proud of it. Me and David did it
Yeah.
a couple days ago.
Uh-huh.
And it's up.
So tell me a little bit more about that, because it looks like your lighter color is kind of solid, and then you just cut some strips into it to be able to do the weave. Is that right?
Yeah.
Well, no, you pulled the whole thing, right?
What?
Like the whole, you made like yarn.
Yeah, they
Yeah.
made the t-shirts into yarn. This was a project of yours that Olympia High School did. So they cut t-shirts and make it into big, long strips of yarn. The white and the gray are big, long strips that they interweaved so that
And
there's a
then
lot of spots.
Yep. You wrapped one color, right? And then
Yeah.
then you put the other color under over.
Yeah, under over.
Oh,
Under
okay.
cover.
The first round was pretty easy because you didn't have to go under over, and then the purple we had to actually weave it through.
Okay. And so now you're playing the game and you take the other person's pawn. What are you going to do? Where are you going to put those so you don't lose them?
That was our Capri Suns melted together idea, kind of like just to make a bag. And then
You could also finger knit.
and then if the heat doesn't work, because we already tried it, we could finger knit them together.
Use more
Huh.
t-shirts.
Yeah. Use more t-shirts.
Yeah.
Okay.
Sorry,
No,
not finger knit the Capri Sun, finger knit the t-shirts together.
yeah, weaving together Capri Suns might be difficult too. So.
Yeah.
Okay. That's all right. Now, just as a thought for you, right? Right now you've got you said you used foam as your backboard, is that right?
Yeah.
Mhm.
Okay. So the requirement is it can't be any larger than 12 by 12, right? But I
Yep.
don't say anything about the height. So if you guys wanted to do something else with the thickness or the height of that board, you've got some room to do that. Does that make sense?
Yeah.
Okay.
Could
What do
make
you
that
think
work.
your next step is, gentlemen?
What's your next step? Pretty good.
Probably mold.
Yeah.
pieces.
Probably the
Molded
pieces.
Yeah,
Try out the molds and
the 3D.
yeah,
print
the
thing.
3D print molds and see if that'll work in our the two different colors.
Yeah. No, I think that sounds really good. I think there's some good options, especially, just for consistency, some kind of molding process, I think is a really cool one. So who's the better chess player?
Probably him.
Are either of you guys in the chess team or anything like that? Do you guys have a chess team?
Oh, we don't have one here at Laurel, but we should.
You know, if you had an excuse to make a chess team, this would be it, right?
Yeah.
Well, I do want you to video yourselves at least playing chess on your board. That's part of your testing, right? We want to see it work.
Yeah.
Well, and actually, that's a really important comment because right now you've got these clips that you want to go under, and I want to know how that works. Is that really a good plan? And going through a couple of games could highlight whether it works well or if it's got a problem that you'd want to change different about it. Does that make sense?
Yeah, we'll definitely test it out. Make
And
sure.
you know what? In sewing, there are these tiny little clips. I have some. I'll show you. They're tiny little clips. Instead of pins, we use these clips. Hold on, I'll get it. Hold on.
Your videos go in there. You probably went in the Arduino. Like the Arduino went in.
So you guys haven't done any sewing right now. You've just done a little bit of weaving. Is that right?
Yeah.
Yeah. Okay.
You think you go black, red, red?
You know, just as a thought, there might be some value to doing some stitching on that. And what I mean is, you probably don't want to stitch all of them, but if you stitched half of the seams that you've got, it may give you a little bit more stability and keep it from shifting on you. Does that make sense?
Yeah.
So here's the pins, and they're real little. So you see they're the size of a safety pin, or a regular pin, but they're so good. And I don't know, you could clip it onto a string of your board and it would work.
Come look at this clip. We actually could do that.
This is from sewing. I bet you your sewing teacher has it.
Yeah.
They're sewing. Yeah, I got them at a sewing store, but I used them when I was making the cargo transfer bag at NASA. They use it all the time. And it's a little clip. And in actuality, you could actually distinguish colors using like all blue for one team and all yellow for another, or something like that.
Yeah. Well, and the difficulty is those would probably not be trash, though. We'd be sending out different, though.
Yes,
but
that's
we should
a good point.
No, take a look at those, though. That's a good idea for some other uses. Good thinking, Flo.
Yeah, I love these little clips. Instead of those sharp pins, these take the place.
Yeah.
I'll bring some when I come.
Sweet, thank you.
Good job, guys. Any other thoughts for us?
I think that's it for now.
Okay. All right. Good job.
Yeah, I like it. I like it.
Who's good at sewing?
We both kind of do it.
Yeah.
Excellent.
Not necessarily good.
School, right?
Yeah, we're not pros.
But
I am no pro, but I can use the sewing machine on occasion. So that's a good idea. Good job, guys.
Yeah. All right. Thank you so much.
Yeah, let's travel.
Yeah.
Okay, we're gonna take you up to the other classroom.
Okay.
Okay. All right, come on. Oh, we'll have to work on that.
I like the idea of a mold.
I'm gonna take these guys. Okay, we have a pop-up tent over here. So we've been using this other room, so I don't have a tent in my classroom.
Oh.
Okay. I think they want to show you part of this pop-up tent. See?
Oh, yeah.
Look at that.
It's full size. It looks like is this the hygiene stall kit team?
Yeah. Yeah. This is
Okay.
Okay.
We bought this so that they could play around with what it felt like to be inside.
Yeah.
Figure out size, like, can they move their arms? Can they take off a shirt? That kind of thing. So.
Very good. So what'd you learn from it, guys?
Good size and whatnot, and we kind of got some new ideas with the steel wire that you typically see inside, like as like a little kid, those tubes and whatnot. We kind of learned a little bit of that, and then just how compact some of those like materials can become, whatnot, because these came in a tiny little circle, maybe about yay tall or so, pretty small, and has relatively good size to it as well.
Good. Okay. So where do you want to go from this thing?
From here, a lot of it was the lighting and seeing how we could manipulate the light to not as many shadows through and whatnot, and what's the best way to light around the area that would be given inside of that. So that was kind of our big part of this.
Makes sense. So what did you find with shadows and stuff like that in there?
From what we've been able to test, that a 360 light around on all edges was the best way to eliminate all light, with light coming from all those directions to help eliminate all those shadows.
So where were you placing those lights? Are you putting it around the top or down the side?
Yeah, just around this top edge there. We were placing them up along that top edge.
Very good. And so with somebody in there and the light around the top, you don't get shadows that that are showing silhouettes or anything?
With this material, it's very thin, so that was our hardest thing too. But with how thin the material was, we were getting very minimal shadows unless you were right up against the material there.
Yeah, that makes sense. Mm-hmm. Very good. Okay, now this thing. So we want to be able to set it up and then take it down relatively quickly. Mm-hmm. Do you want to use this same kind of style, or what are you guys thinking you want to do?
We were thinking about using a different style. So originally with looking at the gateway and the renderings of that as well, kind of getting an idea going off of that and how it could fit in even to that area where there's the blank space in between the actual interior walls and the exterior there. There's a space for a fold up kind of design where it folds up and down, and it would be very compact up against the wall where you wouldn't notice it unless it was folded out. So we were kind of going into a flat area.
You thought the pop-up would be hard to put down without gravity.
Yeah, and if for the pop-up would be hard to collapse in no gravity, since you wouldn't have gravity to actually push it down. So we'd have to do a different method.
Okay. So you can imagine that you've got this kind of an empty place in the shell. Did you guys have some thoughts about how you might attach it to the shell or anything to be able to keep it from floating around while they're changing or doing their hygiene activities?
Keeping it attached to that wall, and even the supports along that where they usually clip in like their tape or whatever else they would clip into that railing.
Or you could do the racks.
Well, and we got to figure, so you guys are able to kind of determine what kind of rails that they might need in that area. And so give that as part of your thought process. Where do you want some kind of a clip or some kind of a, lanyard or something that holds it in place? Is that okay?
Yep.
Let's see. Now, so this one is it 4 different kind of metal rings inside? Is that right?
Yep.
Yeah, there's 4.
Yeah. Okay. What about the hygiene? Do you have anything planned for how you want to put the hygiene kit in there or hold things in place for the crew?
So in the past, Flo has shown us the kits that they make and sew together, one that she's holding up right now. And we're going to utilize that same Velcro on there rather than trying to add something and overcomplicate it.
That sounds good. Now, right now, I think you've got a zipper. Is that right?
Yeah.
What do you want? Do you want to continue with the zipper, or what else? What other options do you have?
Zippers seems to be the most that would seal it up tightly and not have the worry of it breaking apart. Because our only other thing would probably be magnets.
Okay. What about airflow?
Airflow, we've tested around with airflow a little bit, but it's not so much to suck up the water and moisture. There wouldn't be much moisture. It's more so wipes is what we've understood it as. So we just needed an airflow around to keep the carbon dioxide from building up inside of there into one bubble. whatnot. So we've just been kind of messing around with little fans and not something too big that would take up too much space. And
Okay.
we found ones that are only 1.5 inches, 2 inches.
That's all right. How is it? Is it one or two?
It would just be one. The one that we've been using is just one.
Okay. And where do you want to place them?
We were thinking for our final design, it would be easiest on the floor because that's where it fold out of. Everything would fold upwards from the floor down. So it'd be easiest to have it on the floor built in.
So have two of these on the floor?
Probably just one would be enough airflow with a strong enough motor and battery.
Okay. Well, and consider if it's down at the floor, you're not breathing down there. You're looking for a way to have some airflow that kind of comes in across your face, and then you probably want to remove some of it down at the bottom. Does that make sense? Or at least let it out at the bottom.
Yeah.
So like it pulls.
Yeah.
You could just have one look and then top of one something out.
Yep.
Okay.
Switch it.
Yeah.
Well, and also if you try to find some breathable material, that would help, because building up carbon dioxide, the astronaut might get clean, but he'll have a terrible headache at the end.
You did
So,
talk about that Gore-Tex that they use they use it in the military, and they go up in the whole thing and zip themselves up in it, and they can breathe.
Yeah, we found a material. It's a Gore-Tex material. They use it in the military. It's breathable. It's flame resistant and like heat resistant. It's somewhat like this canvas almost material. We thought that would work really good.
But you can't get samples of it. You can tell them that we reached out and asked.
No, and we reached out and asked about getting samples to test with it, and we couldn't get any samples to use ourselves. But there's been a lot of research that's been done on it from other companies.
That sounds good. Now, have you started putting together any portion of your prototype?
We started to make we have a template cut out. We were just about to get around to sewing it all together, getting it put together for the full preliminary.
Okay. Very good.
yeah, and you don't have to use the Gore-Tex. That you just have to tell the NASA reviewers that that's what you want to use, and you could use this green stuff if you wanted, or whatever you have. Does that make sense?
Yep.
Okay. Whoops. Let me turn this up. No, I think this is looking pretty good. Now, do you guys already have like an action figure or something to be able to put in there?
I got Barbies.
Yeah, we were just gonna use a Barbie, so
That's okay. And as long as you've got something there, right? I don't want you to be stealing it from your younger sister or whatever, right? Astronaut Barbie might be the best one, but so okay.
Yeah.
Any other thoughts or questions, guys?
Do you have any questions?
Do you have any questions? So the ease of setting it up and putting it and collapsing it is very important, because that's going to be set up and collapsed a lot. So that's a test. When you do that, take a video and time it. Does that make sense? You want to see? I think the requirement said for 3 minutes, Glenn? What did that say?
Yeah, it's 3 minutes.
Yeah.
And so consider if you want to, it would probably make sense you're making this 1/6 version of your prototype. You might also make the shell of the module, and that way you can see how it fits in there as well. Does that make sense?
Yep.
So
Okay.
am I correct in saying that this isn't in the actual gateway, but it's in the Orion capsule that's going to attach to it?
No, this will
No.
be in the gateway.
Will be in the gateway. Okay.
Yeah,
It will be
it
a
is part of the gateway.
habitat. It will be a habitat that will connect to the gateway.
Yeah, actually, let me back up. So what they want to do, the way they're thinking of this is that there's a supply ship that needs to go to the gateway. And that supply ship is going to have things that are kind of disposable. And so this will be what they will make several of, where each time they send a supply ship there, this would be a part of that supply ship. Does that make sense?
Right. Yeah.
So this is kind of disposable because when the new supply ship comes, this one's going to be sent back and burned up. And then the new supply ship will have a new hygiene stall.
That's right.
Another thing we should probably factor in is how much money it would cost to make one of these. We want to be cost effective.
No,
um,
actually.
Yeah. Yeah. It's not as important. It's important for you to know how much you expect it to cost, but I'm not so worried about what that cost is in terms of, that's too expensive. This is, see if you can cheapen it up or whatever. It's more of give us an idea of how much you think it'll cost. Okay.
Yeah, and that Gore-Tex material might be really expensive that the military use, but it's nothing compared to the $1.2 million a kilogram that it's going to cost us to go there up to this to the gateway. So the real cost is in the transportation, not the material. Does that make sense?
Yeah.
Good questions.
Yeah.
Anything else, gentlemen?
Yeah.
We were wondering, so like height wise and like stability, are we even able to connect it to the ceiling of the habitat or no?
Yeah, I think you can. I mean, I can't remember what's the radius or what's the diameter of the module? Is it like 4 meters or something like that?
Yeah.
I think so. It was 4 or 6.
Yeah, and so just take a look at that and see how you think it'll fit in there. But yeah, there's it's important to be able to kind of place it in there so that you can see how much you really need. Okay.
Yeah, one of our concerns not being able to hook into the ceiling was if I get in this one right now and I try and like pull something off my head, I'm about 6 foot and I can lift this up fairly high above the ground. Just because, so we want to have enough room that we can like reach up.
Yeah. Well, and remember, right now you're making yourself stand up pretty straight. If you are floating, you take on a little bit more of a curved. Your knees come up a little bit, your legs come up a little bit. It's not stooped, but you take up a little bit less space. Is that okay?
Yeah.
Yeah. So
now,
Glenn,
does that one have a floor in it?
No, this one does not have a floor. It's just set up on like the ground.
Okay, and that makes sense. Okay, what were you saying, Flo?
So, number 5 in your new requirements there, it says the hygiene stall collapses into a volume less than 2 by 2 by 4 inches. So if
that's
they
right, and that's the scale, right?
Right, but if they have a fan and the battery and the motor and stuff in the bottom, how's that going to be just 2 by 2 by 4?
Good question. I don't know that one. We're going to have to look at it as you guys progress. We may have to adjust that some, just because of scaling a fan and everything like that may be difficult. So, what she's referring to in the next day or so here, we're going to try to put out put the requirements on each of the pages, and I don't think there's anything new there. We're just trying to make it as easy as we can so that you see what we're trying to get from you. And hopefully, as you look through it, you're going to say, okay, can we match that? And if you have some difficulties, I want you to email me and say, hey, this is the best we can do, or what, how do we fix this? We're trying to make it as doable as possible. Okay.
And the fan we have right now is for a full scale model, like for this tent, not our actual smaller model. So
that's right.
Yeah. But
that might be part of the answer is that you might be 3D printing a mock-up of your fan so that it's scaled appropriately. Does that make sense?
Yeah.
Yeah, that would be good. Yeah.
Okay. Good thinking. That might be a correction I need to make today. So that's good. All right. Any other thoughts, guys?
No, good job. I love the pop-up tent.
I can't wait to I can't wait to see what you guys put together for your model. Good job.
Thank you so much.
Yeah, thank you.
Okay.
Okay.
Now it's my turn.
That's
Hey.
Chase.
Oh, this is Chase. He was in it last year.
Yeah,
Hey,
I did
Chase.
a robot that didn't make it very far, but that's okay.
That's okay. We're working it this year.
Yeah.
Well, and I already told Quiz, or oh my gosh, I was thinking about different words. I already told Flo. I think I'm a lot further this year than I was last year at this point, so hopefully we can make it. But
Excellent.
I'm doing the trash ejector.
Okay, tell me about it.
So I did a model out of cardboard, this ugly thing. And so the way it works is we're gonna use a tube, and for my model I'm doing here, I'll put it over here. The model I'm doing here, I just used a cardboard tube, so it isn't as strong as PVC. But I really liked your idea of using PVC pipe because then I don't have to worry about rails or anything to keep the can straight. The tube just carries it through, launches it straight. It's perfect. And so I ended up getting a cardboard tube to put in here. And so that will work. How it works is I have a plate, and I can probably show you in here. Gonna open all these up. So inside my project here, you can see I've got my can in there, and I've got my ruler. The ruler sits between a plate with springs behind it and then the can. So the plate is right here on this side, and then the can starts right here. And so then when I pull this ruler, and at some point I'll have to figure out how I want to do this because it'll be a clip of some kind. The plate engages and the springs push it out this way. I have my exterior door here, which I was kind of bored after I had it done, so I did put it on a.
Oh, look at that. I like it.
So it's similar to how I'm gonna want my exterior door on the final project, but a little bit different. I'm a little bit worried about how tight it will be, so I think I'll put this on the inside so that when I have this open, the air fills the thing up here, and it can push the door solid against the wall as a sort of seal so that we're not losing any air. But the way it works is you open your exterior door, and because this plate is already compressed, I can pull this out and it launches my
Very good
thing. I'm not sure yet if I want to do 1 spring or 3. Now that I have this out here, you can see my plate in there with my springs behind it.
So you got 3 springs right now, is that right?
Yes. And the issue with 3 springs is since right now I don't have them equally distant from each other, I don't have them spread out equally on the plate. The plate has uneven pressure on one side, so if I pull it back, the plate just tilts and then warps inside. So
how do you compress your springs now?
So now here's my issue. I had a string out here I could pull. I broke it off on accident. So right now I have to actually push this with my fingers and put my can in there. Okay. And I told Flo and Miss Moon earlier, I accidentally made this door too small. So I actually have to put the can in the front here this way, put my ruler in, and then launch. But door size is something I'll be able to play with to get the perfect size on the final one.
Okay. And so I'm okay with how you're doing that. There's nothing wrong it's perfectly fine for an astronaut to have to push the trash into the pusher plate as a beginning. That's not a problem. So tell me, what do you want to do next as you progress with this prototype?
So as I progress, I want to get my PVC tube. This cardboard is weak in it now that I've been working with it for a little bit. It has some battle scars, and so now my tube is a little bit deformed, but you know. But then ultimately I want to 3D print housing for the tube. And then I'll get the tube glued in there with rubber cement or something. An issue I had is when I was putting this can in here at first, my force was so strong that it actually pushed the springs out the back of my project back here when my tube was compressed. So I'm going to 3D print the housing, and hopefully that will give me more strength than the cardboard. And then I'm still working on different options for launching. Right now, I just have this ruler that I've been using that I can put in and then pull out. But I'm looking at different clip options and what I can do for that.
Okay.
The only issue I have with putting the can in the front here is that this is the exterior side of the rocket. So then an astronaut would be on the outside of the rocket to put it in here.
Yeah. So really you're looking at a size problem. Right now you've got your box representing a little bit on a smaller side, but your can is still the same size, right?
Yeah.
Yeah. So it's just whatever your next move is. I think that that's smart. So, for example, I like your exterior door. I think that that's a good idea. There's going to be difficulties with trying to lock that or to keep the air inside. But look at that because there are easy ways to fix that. Okay.
Yeah.
And then in terms of that indoor, interior door, I think that that's actually just fine as well.
Okay.
Now, one thing that you'll want to think about is how can I make I want to make it so that I cannot open that outdoor, the exterior door if my interior door is open. Does that make sense?
Yeah, that would be bad.
And vice versa. And you can do that mechanically as well as electronically. Does that make sense?
Yeah.
Okay. Very good. Another comment for you. As long as you're using chicken noodle soup, right?
Yes, my can got a little damaged. I have the wrapper, but it is chicken noodle.
Oh, that's fine. So my point is, I don't need the wrapper, but if you choose to make something that attaches to your can, I'm okay with that. Okay? So just make sure you want to be making it as minimal of a change as you can if you choose to do that. Okay?
Yeah.
All right. I'm not opposed to your three springs. I think that seems to work okay.
Yeah.
So, yeah, I think some of your problems are just by way of the weakness of the particular box that you've got right now, but you're able to demonstrate a lot of the ideas. So I think it's good.
Thank you. I took a minute. I had to learn some soldering so my button over here would work. That's just my open close button.
Oh, yeah, that's cool.
So I took some time in physics the other day and got out a soldering iron and spent some time getting that working. And then the way I have this now is I can probably open up this side. I don't have my X-Acto knife with me, but I've got batteries in this side, and then my parts, like my wires and stuff, are on this side. And I wasn't sure if I should leave it battery powered or because obviously it'd be wired into the ship at that point, but
well, and I don't have a preference as to how you do that. That's just fine. The idea that you've got, I didn't realize that your door was activated by way of that motor. So that's kind of cool as well. So good job. I like that.
Thank you.
Yeah. Chase, whenever you 3D print something, make sure you don't have any sharp edges or corners. Just round everything off.
Yeah, I've been talking actually with Devin about that to make sure it's all
good. Wow. What size do you think it's going to be in the
I don't see it being too much larger than this. Because my can launches from this direction, it goes like from back here to out here. I do want to make this a little bit longer. Because right now, like I said, my door isn't even big enough to get a can of soup in there.
Yeah, right.
And so I need to get that bigger. But other than that, I think width-wise, I may even be able to shrink it down because I've got a lot of open space over here.
Right, Yeah.
I've got a lot of open space over here. I'm just gonna rip that. Being used by cables in Arduino and stuff. So all this can be shrunk down quite a bit. And
Good.
so I can actually make it smaller this direction, but I will have to make it longer this direction.
I think that makes sense. I think you're on a good path.
But
Well,
in actuality, your PVC pipe could just stick out of that.
Yeah.
You don't have to make the other side where the door swings as the same length as the PVC pipe.
Yeah.
I don't know. I like your design though. So cool.
Another thought for you. Right now you're using a cardboard box, but I think you could probably switch over to,
shoebox.
Well, shoebox is still cardboard, right? But I think if you go over to the hardware store, you can get some fairly small boxes. And one of the places I found that was really valuable were these it's like a square plastic box with a screw lid on it, and it was for mixed nuts. I think I got them at the grocery store. I don't know if that works for you or not, but part of what's cool about it is that it's transparent, and so you're able to see all of your parts. And as you were doing some of this stuff, so it might just be the next step for you, or you can move to anything you like. Okay.
I'll have to see and look. I think you showed me the mixed nuts tub, and I think it's gonna be too small for my project. But I thought maybe I'll go to Walmart and they have those like clear totes, and I could probably find a small one, or even like these. I'll grab one of these first.
Oh yeah, look at that. Those are good.
But these, I think would be good because I don't need the width, so I could actually just cut a hole here for my tube. And my Arduino and stuff would fit over here on the sides.
I think that's a great idea
for that. And then I can always take off the lid to show you the insides.
I think that's a great idea. There's a lot of options there for it.
Yeah.
Good job. I like it.
That would be awesome. Yeah. Do you have any questions for us?
I thought I had one earlier, but now I can't remember what it was. Ideas for the door, because we don't want the way this door works now is it just sits on the outside, and obviously you can just see right in there. So because we want it to be sealed when I open this interior door, what do you think for door options on the exterior?
So, I don't have anything here to show it with. So as your door was coming down, imagine if there was as it came down, there was a lip so that on the outside, I don't know, is my camera working very well?
I mean, it's really laggy, but
yeah, that's what I
your
thought.
Hands are doing. Okay. Yeah. So have a lip on the bottom here.
That's right. So as it comes down, if it's angled a little bit, it would be pushing your door more towards the opening and giving you a seal. Does that make sense?
Yeah. So have it come down like this into this lip.
That's right.
Okay.
And so you would be getting at least, yes, exactly like that.
Okay.
And it, yeah, and you might be able to shape the top of it so that it actually comes into the gasket a little bit more as well.
Okay.
Does that make sense?
Yeah.
And you could have some kind of indicator that when that door is completely closed in the lip, then you know it's closed on your on your trash ejector.
Will actually be really easy, so that's good. The way this code works right now is when I push this button, it doesn't actually know the position of the door, but it sets its position to open when it's open. And then when I push it again, it closes it and sets its position to close. So then I guess I could have something over here, maybe another servo of sorts that will cover the door when this one's position is set to open so that you can't open the interior door when it's
right.
But then I can push the button, and when its status is set to closed, then you can open the interior door.
Right.
Well, consider, those locks where you can just move them back and forth and you can
Yeah.
rotate it. Imagine if you have one that's long enough, when it's positioned over the interior door, it's short enough that the other one will open, right?
Yeah.
And then when you shift it the other direction, it would prevent the exterior door from rotating up, but leaving the interior door so that it could open. So it doesn't have to be complicated. It just needs to be long enough mechanically so that it'll prevent one from moving and the other. Does that make sense?
Yeah.
Mm-hmm. Glenn, what did you think about him putting that swinging door on the inside of his trash ejector so that the air would keep it closed?
That's also a good idea. I like that. That's a smart thought.
Yeah.
Yeah, I
Now-
thought about I could even I could take the PVC tube and I could cut it at some point, and then I could just space it out a little bit, and then I could have the door go in between there, and so when it's closed, the air can't escape through the tube at all. But then when it's open, the can be launched through it just like normal.
I'm okay with that. No, I think that works just fine. Good thinking.
Okay, thank you.
Chase, are you doing this by yourself?
Well, so I was gonna have a partner. So I am doing it by myself.
Okay.
I was gonna have a partner, but he had some unforeseen circumstances, so he hasn't been able to work on it very much.
Okay, that's all right. We know you're
right.
a good partner. We're team playing. Chase was like our captain last year
Excellent.
for
Okay.
everything.
All right. Any other thoughts or questions?
I don't think so.
Let me ask you. So how do you plan to be able to, let's see, you've put the can in, you've closed the door, you need to pull the air out. Do you have a plan for how and where you would pull that air out?
Yeah, so I was thinking, so I was reading through the project, and I don't have a pump or anything. So what I planned on doing was just making the area less than 10% of the volume of the can, so then I didn't have to worry about the amount of air escaping. And especially with at least the size of the project now, when I put this can in here, I've got very little room for air. So I think the amount of air is minute enough where even if you were launching many times, you wouldn't lose that much air.
Okay. Well, and do a calculation on that, because right now you still have that extra section on the where all the electronics are that it would be taking up a lot of air. And it's not that I need you to have an air pump there, but I need you to be able to show me how are you going to pull that, where would you have this located, as well as how are you going to let air back in so that you can open that interior hatch at some point. Is that okay?
Yeah.
All right. Good job.
Thank you.
No, I think it looks good. Just working on that mechanism for how to hold the can in position. Do you have any Nerf guns?
I do, I think, yeah.
So you might look at a Nerf gun and see how they hold, one of the Nerf pellets in place before they launch. And that might help out as well. Some kind of a trigger mechanism.
Yeah.
Okay.
Okay.
Awesome. Thank you, Chase. Thank you, Glenn. So
You bet.
You're the last. Well, we have one at 3:45 your time. Miss Moon, is that right? At 2:45?
Yeah, 2:45. Yep.
Our time.
The Nano Lab Space Crop Kids.
Okay. So we'll come back. Can you come back, Glenn, at 3:45?
I'm meeting with somebody else at 3:45 my time.
That's exactly when we're meeting.
Yeah, so I may not be able to make that one, but I'll see what I can do, okay?
Okay, great.
Okay, we can maybe start. What time does 6th period start?
6th period is already going.
Or no, 7th period.
I don't know.
don't know what they have before me. I don't know what those kids have before me. I know where they're at 7th period, but I don't know where they're at 6th. I might be able to get them to come down earlier.
Okay. All right. I'm at work right now. I'm gonna run home real quick and get plugged in. We'll see what happens. Okay.
Okay.
I'll come back on for a little bit and maybe we can work it out. Okay.
Okay. Thank you. Thanks
All right.
so
I'll
much.
talk to you soon.
Good job.
Okay.
Yeah. Bye-bye.